Today we're going to talk about uncertainty in measurement. We will talk about some vocab terms such as accuracy, precision, and then learn equation called percent error. All measured values have some degree of error, no matter what, if we're using the measuring device correctly, measuring one placed value past what that measuring device happens to be marked. So we're going to include in a measured value all values known for certain plus one estimated place value. And that estimated place value is what we're concerned about here. That estimated place value is going to be limited by human ability and then also mechanical ability of the device. In general, when we talk about measurements, the more place values you go to the right of a decimal, the more accurate they're going to be, and also that tends to make that measuring device more expensive. The quality of the measurement can be described using terms such as accuracy and precision. They mean different things, and commonly students confuse what they mean because they're often interchanged in a more everyday type of situation. When we talk about accuracy, we're talking about how close a given measured value is to an accepted value. Now, what's an accepted value? For the sake of our class, an accepted value is one that I would provide you or a different teacher would provide you. But it's also a value that would be found in a textbook or in a resource that you could find where lots of people have verified that value. So measured value compared to the accepted value. We have a couple different ways that we can look at accuracy. We can either take our measured value and we can round off the last place value, in other words, round off the estimated place value. And if that's the same as the accepted value, we can say that that's accurate. So that's just one definition that we sometimes use in class. Round off the last place value. If it's the same as the accepted value rounded to the same place, we would call that accurate. Another definition of accuracy would be using percent error, which we will look at it in a little bit here. But you could say that for this specific measurement, accurate is within 5% error or 10% error. So this is kind of a relative thing where depending on your situation, a certain level of error is acceptable, and that makes accuracy kind of hard to discuss because of that. For example, if you're talking about giving a little tiny micro preemie baby some medicine, you're probably going to be talking about being very accurate in that situation. On the other hand, if you're talking about putting in a certain amount of cream or sugar into a black coffee, the accuracy is probably not nearly as important in that moment. So one spot that you can find these accepted values would be in the Handbook of Chem and Physics. These are these giant books that are just filled with lots and lots of known values. Another word that we use is called precision. Precision is looking at the accuracy of a group of measurements. So if we have multiple measurements, we can talk were they made with precision would be the phrase you would use. So you have to have at least two measurements. Typically we like to have three when we start to talk about precision. And we're kind of looking for groupings of measurements. Are they repeatable is kind of the phrase that we would use. And like accuracy, we could take our multiple measurements, and if we round off that last place value, are the measurements the same number? So one definition that we can use for precision is yes, they are. And if they are rounded to the same number, we can say they're precise. If they don't round to the same number, we could perhaps say that they aren't precise. So we have some images here to show what accuracy and precision look like. The image would be a bullseye target type situation where you're firing arrows at that bullseye. If you hit the bullseye, we would call that accurate because the accepted shot for firing arrows would be the bullseye. So if your arrows hit the bullseye, that's accurate. So we can talk about accuracy in that situation, but we can talk about precision as well. Precision is, can we put those three arrows all in the same spot? If we put them in the same spot, that's precise. If they're scattered throughout the target, then that wouldn't be precise. So ideally, we want the target at the right where all three arrows hit the same spot. That's precision, and they also hit the intended value. When we talk about measurements, we want to talk about the ability to do precision and to have accurate measurements at the same time. Mathematically, we can examine accuracy by using something called percent error. And percent error is really useful because it compares a mistake to the overall sample. And there again, if you have a small sample, a mistake affects that sample more greatly than a mistake in a larger sample. So that's why percent error is important. And that's also why in labs we try to use as much as we can without being wasteful to minimize the effects of a mistake. When we do that, we're going to take the experimental value, and we call that the one that we see in the lab. So experimental, or sometimes it's called observed. And you have to be able to be flexible with either of those words. So this equation that's shown on the screen, the experimental right here, sometimes it's experimental, sometimes it's observed. Then we're going to subtract from it the actual value, and sometimes it's theoretical. It's the one that you would predict either based on some math, or the one that's given to you by a teacher, or the one that you can look up in a book. But we're always going to take what we collect as a measured value and subtract from that known values from a book or resource or math or something like that, times 100. Notice that the equation has parentheses in the numerator. If you forget about those parentheses, you're going to have an incorrect answer. So that's talking about accuracy and precision in measurements. And these are important things for us to be considering when we are making measurements and when we analyze those measurements.